Hello Sleepy Science subscribers, welcome back to the channel. And before we begin, please remember to like the video and subscribe so that more people can drift gently into sleep with us as we explore the quiet wonders of the universe. Tonight, we begin a calm journey into the early days of our planet, a time when Earth was young, warm, and wrapped in a silence so deep that even the wind had not yet been born. Together, we will explore how the atmosphere formed, how air itself came into existence, and how the soft blanket of gases that surrounds our world slowly emerged from cosmic stillness. As you settle into a comfortable position, allow your breathing to fall into a slow rhythm, and imagine the Earth more than 4 billion years ago, glowing like a newborn ember floating in the quiet darkness of space. The planet's surface was a vast ocean of molten rock, shimmering with deep orange light. There was no sky as we know it, only a thin haze above the scorching landscape, a haze made from volcanic gases rising gently from the cooling crust. The early Earth was a place of fire and silence, yet within this raw and glowing scene, the foundations of the atmosphere were quietly beginning to form. Picture volcanic vents releasing streams of gas into the heavy stillness, water vapor, carbon dioxide, nitrogen, and traces of sulfur drifted upward like soft, ghostly plumes rising into the young sky. These gases did not yet form an atmosphere. They simply collected slowly above the molten surface, held weakly by Earth's gravity. Over millions of years, these gases thickened into a dense primordial envelope, a rough early blanket that wrapped the Earth like a warm shroud. The air was not breathable, not gentle, not cool, but it was the beginning of something that one day would become essential for life. Imagine the constant volcanic activity, acting like a slow and steady heartbeat. Each eruption released more vapor and gas, adding layers to the early atmosphere. The water vapor eventually condensed as the Earth cooled, falling back as rain in heavy warm sheets. These rains were not like the soft drizzle of today. They were intense storms that lasted for millions of years, pouring endlessly from the sky. The rain cooled the planet more and more until vast oceans formed, stretching across the ancient world like calm blue basins beneath the heavy early air. As the ocean settled, the atmosphere began to change. Carbon dioxide dissolved into the water, leaving nitrogen as the dominant gas drifting quietly above the cooling seas. The sky slowly shifted from a hot, toxic veil into a more stable layer, still thick and unforgiving, but beginning to take shape. The Earth's magnetic field also strengthened during this time, forming a protective shield that prevented the solar wind from stripping away the forming atmosphere. Without this magnetic barrier, the young air would have been swept into space, leaving the planet barren and silent. Instead, the atmosphere remained held firmly in place, wrapped gently around the planet. Now imagine the Earth under a sky tinted by volcanic haze. Lightning flickered in the thick clouds, illuminating the oceans below with soft bursts of light. The air was heavy and warm, yet full of potential. Scientists believe that these early conditions created the first chemical reactions that would one day lead to life. In this ancient atmosphere, gases combined and separated, forming new molecules in quiet cycles, driven by lightning, sunlight, and volcanic heat. As your breathing slows, let this image settle softly in your mind. The young Earth wrapped in its first blanket of gases, shaped by fire, cooled by rain, and held together by invisible forces. This primitive atmosphere was harsh, but it marked the beginning of a long and gentle journey through which the air we breathe today slowly emerged. As you drift deeper into this quiet story of the early Earth, imagine the planet slowly cooling beneath a sky that is beginning to change from a thick, glowing haze into a calmer layer of swirling clouds. The young world no longer glows with molten light. Instead, it breathes gently through volcanic vents that rise and fall like slow exhalations. In this tranquil vision, the atmosphere continues its transformation, guided by the steady rhythms of chemistry, time, and the quiet interactions between the oceans and the sky. Imagine the heavy rains that once fell endlessly across the earth, now calming into softer patterns. The enormous storms that once shaped the surface begin to ease as the planet cools. Oceans cover much of the world, smooth and warm beneath a sky rich in water vapor and nitrogen. With each passing 1,000 years, the atmosphere grows more stable, allowing subtle processes to take over. Carbon dioxide dissolves into the oceans, forming carbonates that sink slowly to the seafloor where they rest for millions of years. This quiet cycle gently thins the carbon dioxide in the air, leaving nitrogen and water vapor as the dominant gases. As the seas deepen and settle, imagine small volcanic islands rising from the water, releasing gases into the surrounding air. These islands act like tiny chimneys, feeding the sky with volcanic breath. The gases drift upward, mixing with the thick atmosphere and slowly shifting its composition. The young sun shines faintly through the haze, warming the surface with soft filtered light. Even though the sun was weaker billions of years ago, the greenhouse gases in the atmosphere kept the earth warm enough for oceans to remain liquid. This balance created a peaceful environment where chemical reactions could begin to bloom. Now imagine drifting toward these oceans where something remarkable begins to unfold. In the gentle warmth of the shallow seas, simple molecules come together, forming more complex structures. Lightning strikes the surface, sending glowing currents through the water and air, triggering reactions that create organic compounds. These molecules drift like tiny seeds in a dream, slowly becoming the building blocks of life. The early atmosphere plays a crucial role in this process, providing the gases needed to form these delicate beginnings. Scientists believe that methane and ammonia may have been present in small amounts during this time, adding to the chemical richness of the early air. These gases would have drifted gently above the warm seas, creating an environment capable of producing a variety of organic compounds. Whether life formed in shallow pools, near volcanic islands, or deep at hydrothermal vents beneath the ocean, the atmosphere provided the protective blanket needed for these early steps to occur. Now imagine the Earth entering a long, quiet phase where simple microorganisms begin to appear in the oceans. These early life forms do not breathe oxygen; the atmosphere contains almost none. Instead, it is dominated by nitrogen, carbon dioxide, water vapor, and traces of other gases. Yet the presence of life slowly begins to influence the atmosphere. Some microorganisms use sunlight to power their reactions, producing small amounts of oxygen as a byproduct. At first, this oxygen reacts with minerals in the ocean, disappearing as quickly as it forms. But slowly, over millions of years, these reactions begin to shift. Imagine drifting above the ocean surface as tiny bubbles of oxygen rise quietly from ancient microorganisms below. The amount is still small, barely enough to change the color of the sky, but it marks the beginning of one of the most important transitions in Earth's history. The atmosphere is no longer only shaped by geology. Now biology has begun to leave its first gentle fingerprints upon the air. As your breathing softens, imagine the Earth covered by calm oceans beneath a sky that is slowly becoming clearer. Volcanic gases still drift upward, but the storms have settled. The crust has cooled, and early life has begun influencing the atmosphere in subtle ways. It is a world in transition, guided by quiet cycles of chemistry and the first whispers of biology. The air is still unbreathable, but the seeds of change are already drifting through the sky like faint sparks waiting to grow. Let this image settle in your mind, the Earth softly reshaping its own atmosphere through slow and patient processes, preparing the world for the next great transformation that will bring oxygen into the sky. As you drift deeper into the calm history of our planet, imagine the Earth entering a long and gentle transformation, a time when the atmosphere begins to shift from a silent blanket of volcanic gases into something more dynamic, shaped not only by the geology of the planet, but by the earliest living organisms. The oceans stretch beneath a dim young sun, and the sky above them is thick and hazy, tinted by gases that would be hostile to us today, yet essential for the next slow unfolding steps. Imagine yourself floating above these ancient oceans, watching the first photosynthetic microorganisms quietly spread across the warm, shallow waters. These tiny beings resemble soft green films drifting on the surface, absorbing sunlight with delicate stillness. They release oxygen in small amounts, letting it drift upward like faint bubbles rising toward the sky. At first, this oxygen reacts with the iron dissolved in the oceans, forming rust that sinks to the seafloor in quiet layers. These layers, known today as banded iron formations, are the geological memories of those early breaths of oxygen. For millions of years, this process continues with gentle patience. Oxygen is produced but never accumulates because the oceans absorb it as fast as life can create it. The atmosphere remains dominated by nitrogen, carbon dioxide, and water vapor, forming a thick and warm envelope around the planet. Yet something is changing beneath the surface, a slow but steady shift that will eventually reshape the entire world. Now imagine drifting deeper into the oceans where microbial mats grow along the seafloor, forming colonies that spread like soft carpets. These ancient organisms continue releasing oxygen into the water, feeding the slow chemical reactions that prepare the planet for a major transition. Over time, more iron becomes locked in the ocean sediments, and the capacity of the water to absorb oxygen begins to decline. The oceans, just like a cup slowly filling, eventually reach a point where they can hold no more. When that moment arrives, oxygen begins to rise freely into the atmosphere rather than being consumed by the oceans. There is no sudden change, no violent eruption, only a gradual and quiet accumulation that builds over millions of years. The sky begins to transform as oxygen interacts with sunlight, forming ozone, a gas that drifts into the upper atmosphere. This newly formed ozone layer becomes a soft shield protecting the Earth from harmful ultraviolet radiation and preparing the surface for more complex forms of life. Scientists call this shift the Great Oxygenation Event, a slow dawn when the atmosphere began filling with breathable air long before any creatures emerged to use it. The process was not smooth. It brought gentle benefits and quiet challenges. Some microorganisms that thrived in oxygen-free conditions struggled to survive, and many faded into the deep corners of the biosphere. Others adapted, creating new biological pathways that could use oxygen as a powerful source of energy. As you float above this transforming world, imagine how the sky slowly changes color. The thick haze begins to thin as carbon dioxide levels drop and oxygen levels rise. The sunlight becomes brighter and clearer, no longer filtered through heavy clouds of volcanic gases. The oceans deepen in color, turning from a dense, murky tone to the softer blues we know today. Life in the ocean becomes more diverse, feeding on the energy that oxygen makes possible. This new atmosphere allows the Earth's climate to settle into a gentler rhythm. The greenhouse gases that once kept the planet very warm begin to decline, leaving space for a more stable and balanced climate. The air becomes a mixture of nitrogen, oxygen, and traces of other gases, forming the early foundation of the sky we breathe today. Transformation is slow, steady, and deeply peaceful, shaped by the quiet labor of microorganisms drifting beneath the waves. Now imagine the ozone layer thickening in the upper sky, forming a calm, protective shield. It stretches like a soft veil across the planet, filtering the harsh radiation from the sun and allowing the surface of the Earth to cool and stabilize. Without this layer, future life on land would never have been possible. It becomes one of the most delicate yet essential features of the atmosphere, crafted not by storms or volcanism, but by the gentle work of ancient microbes. As your breathing slows, let the image of this early Earth settle softly in your mind. The atmosphere is still evolving, but it has taken on a new form shaped by life itself. The sky is no longer a hostile haze, but a slowly clearing window opening the way for the next chapters of biological and planetary transformation. As you drift deeper into the quiet timeline of our planet, imagine the Earth after the Great Oxygenation Event settling into a new and gentler rhythm. The sky above is clearer than before, and the oceans shimmer with deeper shades of blue. Oxygen now floats freely in the air, rising slowly and steadily from the work of countless microorganisms that continue their silent cycle beneath the waves. The atmosphere is no longer an unchanging blanket of volcanic gases. It has become a living system shaped by the planet and the life that inhabits it. Imagine yourself gliding across the surface of the ancient ocean as oxygen continues to gather in the air. The sky carries a faint scent of transformation, a subtle shift in color and clarity. Sunlight passes through fewer haze particles now, allowing soft beams to reach the water in ways that had never happened before. These new conditions create gentle opportunities for life, encouraging the earliest organisms to diversify and adapt. The atmosphere becomes a quiet partner to evolution, offering new possibilities with each small change. Now imagine drifting above shallow seas where stromatolites grow in slow, layered formations. These ancient structures formed by microorganisms rise like soft, rounded towers from the ocean floor. As they photosynthesize, they continue to release oxygen into the air, shaping the composition of the atmosphere with every gentle breath. Over millions of years, these quiet communities play a significant role in raising oxygen levels, not through sudden bursts, but through patient accumulation. As the atmosphere changes, so does the climate. The reduction of carbon dioxide cools the planet gradually, allowing periods of ice to spread across the continents. Imagine drifting above an Earth covered in vast sheets of white, glaciers stretching calmly across the land. These global glaciations, known as snowball Earth events, are thought to have occurred several times in the deep past. Though harsh in appearance, they helped regulate the atmosphere by trapping carbon dioxide and allowing oxygen to build more steadily. Even extreme changes unfold slowly on this ancient world, shaping the sky little by little. Now picture the oceans during these icy ages. Beneath the frozen surface, life continues its quiet work, sheltered by the water below. Microorganisms still release oxygen into the atmosphere, even while the world above remains still and silent. This oxygen slowly accumulates until the climate warms again and the ice retreats. With each cycle, the atmosphere grows more complex, carrying traces of gases that support more diverse forms of life. After these ancient ice ages end, imagine the Earth warming gently. As volcanic activity increases and continents shift, the skies begin to hold new gases produced by both life and geological processes. Oxygen rises further, nitrogen remains steady, and traces of noble gases drift quietly among them. The atmosphere begins to resemble something closer to what we know today, though still not fully developed. Each layer of the sky becomes a record of slow transformations guided by chemicals, sunlight, oceans, and emerging ecosystems. Now imagine drifting into a time when eukaryotic life appears, a more complex form of cell that uses oxygen to generate energy more efficiently. This new biology accelerates the changes in the atmosphere. As eukaryotes spread through the oceans, they breathe oxygen and release carbon dioxide in balanced cycles that shape the chemistry of the air. The relationship between life and atmosphere deepens, becoming a peaceful exchange that maintains the planet's stability. As you float slowly above the planet, the sky now contains meaningful amounts of oxygen, allowing new pathways of evolution to open. The oceans begin to host more complex organisms, forming early food webs that rely on oxygen for survival. The atmosphere becomes a gentle scaffold that supports the growth of biodiversity, offering protection from radiation and enabling energy-rich metabolic processes. Imagine the ozone layer high above the Earth strengthening as oxygen reacts with sunlight. This layer becomes a calm barrier that shields the surface from harmful ultraviolet rays. Without it, life would remain confined to the oceans, but with it, the possibility of life on land begins to form slowly and quietly. The protective veil rests like a soft, transparent dome over the world, ensuring that future organisms can explore new environments. As your breath deepens, imagine the Earth now wrapped in a balanced atmosphere shaped by billions of years of patient processes. It contains nitrogen as its stable foundation oxygen, as its breath of life, and other gases, in delicate amounts that contribute to weather, climate, and biological cycles. The transformation has been slow, gentle, and monumental, turning a fiery newborn planet into a world capable of supporting vibrant life. Let this vision settle softly in your thoughts, a reminder that even the most powerful changes unfold with calm persistence, and that the sky we breathe today is the result of a quiet journey spanning nearly the entire history of our planet. As you drift further through the long and quiet history of Earth, imagine the atmosphere continuing its slow transformation, becoming more stable, more layered, and more finely tuned to support the life that is gradually evolving above and below the oceans. The sky stretches like a soft blue blanket across the planet, holding within it the memory of volcanic breath, ancient storms, icy ages, and the silent work of microorganisms. Each step has been gentle yet monumental, shaping the world into something capable of supporting astonishing complexity. Imagine now the period when oxygen becomes firmly established in the atmosphere. As oxygen levels rise, new forms of life begin to appear in the oceans. Organisms that use this gas to generate energy with far greater efficiency than their ancestors. These early aerobic beings drift gracefully in the water columns, glowing faintly as sunlight filters through the waves. Their metabolisms release carbon dioxide back into the air, creating a balanced exchange between life and the sky. With each quiet breath, the atmosphere becomes more refined and more stable. Now imagine drifting closer to the surface of the ocean, where the first tiny plankton float in the sunlight. These organisms are small, delicate, and abundant, filling the upper waters with soft movements. Through photosynthesis, they continue releasing oxygen, creating gentle rhythms that influence the entire planet. As plankton spread across the seas, they play a major role in regulating the chemistry of both the ocean and the atmosphere. Their presence marks a new chapter in the long story of the sky. Picture the continents shifting slowly as the Earth's crust moves with patient geological motion. Mountains rise and erode, volcanic arcs appear and disappear, and shallow seas flood across wide regions of land. These changes influence the atmosphere quietly, by altering the gases released from the crust, and by providing new habitats for life. The interplay between geology and biology becomes more complex as time passes, creating cycles that regulate the air with remarkable balance. As oxygen becomes more abundant in the atmosphere, imagine how it reacts with methane, another gas present in small amounts. Methane is a strong greenhouse gas, and when oxygen increases, methane begins to decline. This shift cools the planet, gradually creating a climate that allows for more stable weather patterns. Clouds begin to form higher in the sky, winds develop in soft global patterns, and the first hints of a modern atmosphere emerge. The sky is no longer a haze. It is becoming clear, structured, and breathable for future forms of life. Now imagine drifting through the upper atmosphere, where molecules of oxygen interact with ultraviolet sunlight, forming ozone. The ozone layer strengthens further during this time, becoming a protective shield that prevents harmful radiation from reaching the surface. Beneath this shield, life begins to move toward the land, exploring the shallow edges of ancient coastlines. Without this calm, transparent barrier, evolution would remain trapped beneath the waves, yet now the pathway to land begins to open. As plants and algae spread across shallow coastal areas, they continue releasing oxygen at even greater rates. Imagine early plant-like organisms covering rocks and tidal flats, forming soft green carpets that sway gently in the breeze. Their photosynthesis enriches the atmosphere, further raising oxygen levels to a point where animal life can begin exploring new possibilities. The atmosphere becomes a partner in this transition, offering the gases needed for respiration and protection. Now let your thoughts wander to the possibility that cosmic influences may have played a subtle role in shaping the atmosphere. Some researchers speculate that changes in Earth's orbit, solar cycles, or even distant supernova explosions might have influenced atmospheric chemistry over millions of years. These ideas remain speculative, but they contribute to the gentle understanding that the atmosphere is shaped by both earthbound processes and cosmic rhythms that unfold across vast timescales. As the atmosphere stabilizes even more, imagine drifting across the planet as winds become steady currents that move air from one region to another. Weather systems begin forming with calm predictability, creating rain patterns that nourish early ecosystems. The water cycle becomes a soft heartbeat of the planet, with evaporation, condensation, and rainfall working together to refresh the oceans, lakes, and rivers. This cycle helps maintain the balance of gases in the atmosphere, ensuring that oxygen, carbon dioxide, and nitrogen remain in harmonious proportions. Finally, imagine looking down at the Earth, covered with early forests and sprawling, ancient seas. The sky above is now a stable mixture of gases similar to what we breathe today. It is clear, protective, and life-giving, shaped by billions of years of slow interactions. The atmosphere has become a quiet guardian, holding warmth, shielding from radiation, and supporting the growth of life in all its forms. As your breathing slows, let this image settle gently into your mind. The atmosphere forming layer by layer, shaped by time, life, and cosmic influences, until it becomes the soft blue sky that wraps our world in calmness. As you drift further into the unfolding story of Earth's atmosphere, imagine a world entering a period of growing complexity, a time when life on land begins to take its first tentative steps beneath a sky that has finally become protective enough to allow such a journey. The air above the planet now carries a calm and stable blend of gases shaped by countless cycles of biology, geology, and ancient climate. This atmosphere, still evolving but familiar in many ways, supports new forms of life that rise gently from the oceans and explore the world above water. Imagine yourself floating over shallow coastal regions where early plants begin to spread across damp soil. These plants are simple and small, yet their presence marks a profound shift. Through photosynthesis, they release oxygen into the air, reinforcing the balance that microorganisms had built over billions of years. The atmosphere responds quietly to this change as oxygen levels slowly rise, allowing for new pathways of life to emerge. The sky becomes a more breathable and gentle space, a soft chamber filled with possibilities for evolution. Now imagine drifting through forests of ancient ferns and towering mosses that cover the land during the Paleozoic era. These lush green environments absorb carbon dioxide and exhale oxygen, contributing to the enrichment of the atmosphere. The air becomes thicker with life-sustaining gases, while the protective ozone layer continues to strengthen high above. Winds move softly across these early forests, carrying moisture, seeds, and spores, shaping ecosystems that thrive under the stability of the sky. During this time, the rise of land plants contributes to another quiet transformation. As large trees and dense vegetation spread across continents, carbon dioxide is drawn from the atmosphere and stored in organic material. Over millions of years, some of this material becomes buried beneath sediments, eventually forming coal. This process slowly reduces greenhouse gases, contributing to cooler climates and more balanced weather patterns. Through this gentle climate regulation, the atmosphere and biosphere begin to act as partners, maintaining a peaceful equilibrium. Imagine drifting above wide swamps where early insects begin to take flight. These ancient creatures breathe oxygen directly from the air, a possibility that exists only because the atmosphere has reached a composition rich enough to support them. Some insects grow enormous compared to modern ones, partly due to the high oxygen levels of the time. Their wings beat slowly through the humid air, creating a soft buzzing that fills the ancient forests with gentle motion. This is one of the first moments when animal life truly embraces the sky. Now imagine the oceans below, still producing oxygen through vast fields of plankton that shimmer near the surface. These microscopic organisms continue to play a quiet but central role in maintaining atmospheric balance. As plankton die and sink to the seafloor, they remove carbon from the system, allowing oxygen to accumulate further. This slow cycle acts like the breathing of the planet, a steady inhale and exhale that regulates the climate and the composition of the air. As you glide higher, imagine reaching the upper atmosphere where the ozone layer forms a calm and stable shield. This layer absorbs much of the sun's ultraviolet radiation, preventing it from reaching the surface. Without it, life on land would be scorched by intense radiation. But with it, the Earth enjoys a gentle filtering of sunlight that makes complex ecosystems possible. This quiet protection is one of the atmosphere's most delicate gifts, formed through the presence of oxygen and sustained by natural chemical cycles. There are also more speculative ideas that add soft layers of intrigue to the story of the atmosphere. Some researchers wonder whether cosmic events such as gamma-ray bursts or supernovae may have briefly altered atmospheric chemistry in the deep past. These events could have changed ozone levels or influenced the amount of nitrogen oxides in the air. While evidence is limited, the possibility serves as a gentle reminder that the Earth's atmosphere is not isolated, but part of a larger cosmic environment shaped over eons by both terrestrial and celestial rhythms. As plants and animals spread across the continents, imagine the atmosphere continuing to develop its familiar structure of layers. The troposphere becomes the realm of weather where clouds drift and winds travel. The stratosphere holds the ozone layer, calm and steady. Higher layers like the mesosphere and thermosphere stretch into quieter and thinner regions, where particles drift slowly and softly. Each layer has a role, and together they form the delicate architecture of the sky. As your breathing slows, picture the Earth beneath you as a world wrapped in a blanket of air shaped by life over billions of years. The sky carries the signature of every organism that lived and every chemical cycle that unfolded. It holds warmth, distributes moisture, protects from cosmic radiation, and makes the planet a place where life can grow in endless forms. Let this vision settle softly into your thoughts as you drift deeper into calmness, knowing that the atmosphere we depend on is the product of slow, gentle, and harmonious changes that shaped the planet into the peaceful world we see today. As you drift further along the long timeline of Earth's transformation, imagine the world entering a period when the sky begins to take on a more recognizable form. The air is becoming clearer, the winds more organized, and the patterns of weather more stable. The atmosphere is no longer only a product of volcanic gases and ancient microorganisms. It has become a complex living system shaped by forests, oceans, land masses, and an increasingly diverse web of life. Each breath of oxygen released by a living being contributes to the gentle shaping of the sky, creating a calm and balanced mixture that supports the unfolding tapestry of evolution. Imagine drifting above ancient shorelines where plant life continues spreading inland, following rivers and wetlands. With each new forest, oxygen increases slightly and carbon dioxide decreases. The forests create their own microclimates, releasing moisture into the air and helping clouds form. These clouds drift over the land in soft clusters, delivering rain that nourishes ecosystems and shapes the soil. The air becomes part of a larger cycle, connecting the sky to the land and the sea in gentle, repeating patterns. Now imagine the oceans deepening in complexity as new life forms evolve. Larger animals begin to swim through the water, breathing oxygen and releasing carbon dioxide in calm rhythms. The ocean and atmosphere communicate through the surface, sending gases back and forth in a quiet exchange. Warm waters release carbon dioxide, while cold waters absorb it, creating a natural balance that stabilizes the climate. This gentle exchange is one of the most important relationships on the planet, linking the atmosphere to the vast blue depths. As continents drift across the globe, imagine how their movement alters atmospheric circulation. Mountains rise, forming barriers that redirect winds and create rain shadows. New landmasses break apart, forming coastlines that influence weather patterns. The atmosphere responds to these changes with slow shifts in climate, creating warm periods and cool periods that guide evolution across millions of years. Even geological movement becomes part of the sky's story, shaping the flow of air with calm inevitability. Now picture the skies of the Carboniferous period, when oxygen levels reached some of the highest values in Earth's history. Forests of giant ferns and towering plants covered the continents, and the air was rich and dense with oxygen. Insects grew larger than they ever would again, gliding through the humid air with slow, deliberate motion. This high oxygen environment allowed life to experiment with new forms and sizes, creating ecosystems filled with lush growth and strange creatures. The atmosphere during this time felt heavy with life, yet still balanced and calm. As your mind floats through this era, imagine the slow burial of organic material deep beneath swamps and forests. Over millions of years, this buried material becomes coal, locking carbon away and leaving the atmosphere enriched with oxygen. This slow carbon storage helps cool the climate and prepares the Earth for the next stages of atmospheric evolution. It is another reminder that geological and biological processes work together in quiet harmony, shaping the air that surrounds the planet. Now imagine drifting forward through time into the early Mesozoic era, when dinosaurs begin to roam under skies filled with warm winds and shifting climates. The atmosphere now resembles something close to the modern mixture, though carbon dioxide levels are higher and global temperatures warmer. Volcanoes release gases that warm the climate while oceans regulate the composition of the air. The cycles remain slow, subtle, and interconnected, creating stable environments for new species to emerge. Speculative ideas also add a gentle layer of intrigue to this time. Some scientists suggest that meteor impacts may have introduced new elements into the atmosphere or triggered temporary changes in climate. Others imagine that fluctuations in the sun's activity could have influenced atmospheric chemistry in delicate ways. These cosmic interactions remind us that the sky is shaped not only by Earth itself, but by the larger environment of the solar system drifting quietly around it. As more complex animals evolve, imagine them breathing the air, creating ecosystems that rely on oxygen for survival. Birds begin to take flight, their wings slicing through the atmosphere with grace. Their lungs are among the most efficient in the animal kingdom, allowing them to soar high above mountains and forests. The sky becomes a shared space where life interacts with wind clouds and sunlight. Evolution and atmosphere weave together, forming a calm partnership that supports the beauty of the natural world. As your breathing softens, imagine the atmosphere, now composed of layers that have settled into familiar roles. The troposphere carries weather, the stratosphere holds the ozone layer, the mesosphere cools into thin air, and the thermosphere stretches into the edge of space. These layers move quietly, each fulfilling its purpose to protect, to warm, to circulate, and to allow life to thrive. Let this image settle gently in your mind as you float through the quiet history of the sky, feeling how the atmosphere develops shape by shape, layer by layer, into the calm, protective blanket we know today. As you drift deeper into the unfolding story of Earth's atmosphere, imagine the planet entering a time when the sky becomes increasingly stable, forming recognizable patterns of climate, weather, and seasonal cycles. The mixture of gases has matured into something close to what we know today, yet countless gentle interactions continue shaping the atmosphere with quiet persistence. Every forest, every ocean current, every geological shift sends subtle ripples into the air, weaving a calm and interconnected system that evolves with the Earth itself. Imagine floating above the Triassic landscape where the supercontinent Pangaea stretches across much of the world. The vast landmass alters atmospheric circulation, creating long, dry interiors and humid coastal edges. Winds sweep across deserts, carrying fine dust into the sky, while monsoon patterns develop along ancient coastlines. The atmosphere responds by creating large cells of rising warm air and descending cool air, forming a global pattern that slowly becomes the blueprint for modern climate systems. Even on a planet so different from today, the sky works gently to balance temperatures and distribute moisture. Now imagine drifting slowly across the oceans of this era. Marine life continues to grow in diversity, releasing oxygen and absorbing carbon dioxide in quiet cycles that help regulate the composition of the air. The oceans act as a vast reservoir that breathes with the atmosphere, storing gases during cool periods and releasing them during warm periods. This ongoing exchange acts as a stabilizing force that smooths the climate across millions of years. The atmosphere becomes not just a blanket around the world, but a partner to the ocean in maintaining planetary harmony. As continents shift and break apart, imagine new coastlines forming, each one influencing local climates. When land masses drift toward the poles, ice begins to form, creating bright reflective surfaces that send sunlight back into space. This slow cooling effect interacts gently with the atmosphere, lowering global temperatures in gradual steps. When continents drift closer to the equator, warm currents develop, shaping rainfall patterns and increasing humidity. These interactions between land, ocean, and air form the quiet choreography that guides the evolution of the atmosphere. Now imagine drifting into the Jurassic period, when forests of conifers, cycads, and ferns spread across much of the world. These forests release enormous amounts of oxygen through photosynthesis, creating a fresh and vibrant atmosphere. The air becomes filled with the scents of ancient trees and soft organic compounds that drift upward into the sky, forming the earliest hints of natural aerosols. These tiny particles help clouds form by allowing water vapor to condense around them. The result is a gentle increase in rainfall patterns and the creation of stable cloud cycles that nourish ecosystems across the planet. Speculative ideas also add depth to the story. Some scientists wonder whether volcanic eruptions during this time injected fine ash and sulfur compounds into the stratosphere, temporarily altering climate patterns. These particles could have cooled the planet for short periods by reflecting sunlight, creating episodes of gentle climate variability. Others imagine that occasional asteroid impacts may have briefly changed atmospheric chemistry, sending shock waves through the sky. Though rare, these events could have influenced the evolution of life and the long-term composition of the air. As you drift further, imagine entering the Cretaceous period, when flowering plants begin to appear. Their arrival adds a quiet but significant change to the atmosphere. Flowering plants use water and carbon dioxide, efficiently releasing oxygen in consistent rhythms that help stabilize the air. Their pollen and scents drift through the sky, forming new natural compounds that interact with moisture, wind, and sunlight. These interactions shape cloud patterns, influence rainfall, and gently modify local climates. The atmosphere thus becomes increasingly tied to the evolution of plants, creating a deeper connection between life and sky. Now imagine large marine reptiles gliding through warm, shallow seas while birds take to the air above them. Each animal breathes in oxygen and releases carbon dioxide, forming a global chain of respiration that links land, ocean, and atmosphere. Even though evolution creates new forms, the atmospheric cycles remain steady and calm, allowing life to flourish on a planet that is humbly balanced by invisible gases drifting through the sky. As the Cretaceous period continues, Earth experiences warm, stable climates with high sea levels and lush vegetation. The atmosphere maintains this warmth by holding greenhouse gases in gentle equilibrium with the oceans and biosphere. Clouds form in slow, sweeping patterns, winds move predictably across continents, and storms follow familiar seasonal paths. It is a world where the air acts as a gentle guide, shaping ecosystems with patience rather than force. As your breathing softens, imagine the atmosphere by this point as a finely tuned system built by billions of years of quiet cooperation between life and geology. Each molecule of gas carries the memory of countless cycles, rising, falling, dissolving, and re-emerging as part of an endless planet-wide rhythm. Let this vision settle into your mind as you float deeper into calmness, knowing that the atmosphere has become a peaceful and stable companion to life long before humans ever walked beneath its blue and gentle sky. As you drift farther along the serene timeline of Earth, Imagine the world approaching the end of the age of dinosaurs, a time when the atmosphere has grown stable and full of gentle rhythms that support vast forests, warm oceans, and thriving ecosystems. The air that drifts across the planet now carries familiar patterns of wind, humidity, and sunlight, forming a soft and protective blanket around the Earth. This atmosphere has matured through billions of years of quiet cooperation between geology, life, and cosmic influences, creating an environment capable of supporting extraordinary diversity. Imagine floating above the Cretaceous forests where towering trees sway gently beneath warm breezes. The oxygen-rich atmosphere supports intense biological activity from insects to enormous dinosaurs. Each breath taken by these creatures influences the delicate balance of gases in the sky, linking land and air in a quiet, continuous exchange. The atmosphere carries moisture from the oceans to the continents, where rain feeds the forests and returns to the sea through rivers. This water cycle acts as a soft and steady heartbeat that keeps ecosystems alive. Now imagine drifting higher above these forests into the region where clouds form. Here, tiny droplets gather around small particles carried into the air by wind plants and volcanic eruptions. These droplets become clouds that drift across the sky in slow, graceful formations. Clouds reflect sunlight, regulate temperature, and shape rainfall patterns, forming a peaceful partnership with the atmosphere. Each cloud is a delicate structure born from interactions between water vapor temperature and tiny aerosols that float through the air. As the continents shift and volcanic activity continues, the atmosphere responds with gentle adjustments. Large volcanic eruptions release gases such as sulfur dioxide into the stratosphere, creating thin layers of reflective particles. These layers can cool the Earth temporarily by sending sunlight back into space. Although short-lived, these cooling effects add subtle variations to the climate, creating gentle cycles that influence evolution. Over time, the atmosphere absorbs these changes, returning to a stable state as the dust slowly settles. Imagine drifting over the ancient seas where the ocean and atmosphere continue their slow exchange of gases. Warm, shallow waters release carbon dioxide into the air, while colder, deeper regions absorb it. This interaction forms one of the most important regulatory systems on the planet. When oceans store more carbon, the atmosphere cools, and when oceans release carbon, the atmosphere warms. This balance shapes long-term climate trends, guiding the evolution of ecosystems with patient rhythm. Now imagine the moment when a massive asteroid enters the atmosphere near the end of the Cretaceous. As it descends through the sky, it compresses the air in front of it, generating intense heat and shockwaves. When it strikes the Earth, the impact sends particles into the upper atmosphere, forming a thick cloud of dust and aerosols. These particles reflect sunlight, dramatically reducing global temperatures. While this event brings sudden and harsh consequences, it also demonstrates the atmosphere's ability to interact with cosmic forces. Over time, the dust settles, the skies clear, and the atmosphere gradually returns to its calm and balanced state. With the dinosaurs gone, mammals begin to rise under the changing climate. Their breathing patterns, behaviors, and habitats influence the composition of the air, just as earlier life forms did. Forests regrow across warm regions, absorbing carbon dioxide and releasing oxygen. Grasses begin to spread, forming plains where herbivores graze and predators roam. The atmosphere drifts gently over these landscapes, shaping climate, seasons, and winds that guide the flow of life. Now imagine drifting into the Paleogene period, when Earth warms again after the asteroid dust fades. Rainforests spread toward the poles, creating humid environments with abundant oxygen. Birds fill the sky with soft beating wings, while small mammals take to the trees under this warm, inviting atmosphere. The air now carries the scent of evolving plants whose leaves release organic compounds that drift upward, forming natural aerosols. These compounds help shape cloud formation and even influence rainfall patterns. The atmosphere thus becomes more connected than ever to the life that thrives beneath it. Speculative ideas also enter the story. Some researchers wonder whether cosmic events, such as shifts in solar radiation or nearby supernova explosions, may have subtly altered atmospheric chemistry during these periods. Perhaps periods of increased cosmic rays influenced cloud formation or ozone levels. Though evidence is not certain, these possibilities highlight the idea that the atmosphere is part of a larger cosmic network responding gently to signals from beyond Earth. As you float high above the Paleogene world, imagine the layered structure of the atmosphere fully formed and stable. The troposphere carries weather systems shaped by warm and cool currents. The stratosphere holds the ozone layer, protecting the surface from harmful radiation. Higher layers reach into space, gradually thinning until they merge with the solar wind. Each layer plays its part in shaping the gentle harmony of the planet. As your breathing slows, let this image rest in your mind. The atmosphere has become a calm guardian shaped by life, by oceans, by continents, and by cosmic events. It is a soft and protective blanket drifting steadily around the Earth, guiding the climate and supporting evolution with quiet strength. As you drift further along Earth's long and gentle history, imagine the planet settling into an atmosphere that is becoming increasingly recognizable. The air now holds a balance of gases, similar to what we breathe today, shaped by millions of years of photosynthesis, geological cycles, and interactions between land, ocean, and life. The sky above is clear in some places, cloudy in others, moving with soft winds that trace patterns across the continents. This calm but dynamic system continues to evolve, shaping climates, ecosystems, and the future of life on Earth. Imagine drifting over the Eocene world when the planet enters a warm and stable period. Forests stretch toward the poles, and the air feels thick with moisture and fragrant organic compounds released by leaves. The atmosphere carries warmth evenly across regions, creating mild winters and gentle summers. With fewer temperature extremes, ecosystems flourish, and new species appear in the forests, seas, and skies. This warm period demonstrates how the atmosphere can create a peaceful balance when greenhouse gases remain steady and climates stabilize. Now imagine drifting toward the oceans, where plankton continue their quiet cycles of absorbing carbon dioxide and releasing oxygen. These tiny organisms form the base of marine food webs, and their photosynthesis remains one of the most important contributions to the chemistry of the atmosphere. As they sink after death, they remove carbon from the surface, allowing oxygen to accumulate further. This slow carbon burial shapes the long-term climate, keeping the air in equilibrium for millions of years. As continents drift further apart, ocean currents strengthen, creating a global circulation that transports warm and cold water around the world. This circulation influences the atmosphere by regulating temperatures and shaping wind patterns. Warm currents heat the air above them, creating moisture-rich winds that bring rain to distant continents. Cold currents cool the air, causing dry and stable conditions. The ocean and atmosphere work together like two gentle partners, maintaining a balanced climate. Imagine drifting across mountain ranges that rise and fall through time. When mountains rise, they push air upward, forming clouds and increasing rainfall on one side while creating dry regions on the other. These changes influence the distribution of ecosystems and the cycling of gases in the atmosphere. As mountains erode over millions of years, the sediments they produce carry nutrients to the oceans, enhancing plankton growth and subtly affecting atmospheric composition. Even the quiet rise and fall of mountains helps shape the story of the sky. As the Earth cools gradually over millions of years, the atmosphere responds. During the Oligocene, ice begins to appear in Antarctica, forming large sheets that reflect sunlight back into space. This cooling effect lowers global temperatures and changes wind patterns. The expansion of ice marks an important step in the formation of modern climate cycles. The atmosphere adjusts with quiet precision, balancing greenhouse gases and maintaining a stable mixture for life. Now imagine drifting forward into the Miocene, when grasses spread across the continents, creating wide open landscapes that transform ecosystems. Grazing animals evolved to thrive on these new plants, and their movements influence soil and vegetation, which in turn affect the atmosphere. Grasslands release different organic compounds than forests, shaping cloud formation and regional rainfall. The sky becomes part of a delicate feedback loop, where land and life influence the air and the air influences the land. Speculative ideas also drift through this part of the story. Some scientists wonder whether dust carried through the atmosphere from expanding deserts may have affected climate patterns by reflecting sunlight or fertilizing distant oceans. Others imagine that oscillations in Earth's orbit could have shifted atmospheric circulation, encouraging periods of cooling and warming. These ideas remain gentle possibilities, yet they highlight the interconnectedness of Earth's systems over deep time. Imagine drifting through the Pliocene when global temperatures continue to cool, and the first signs of large-scale glaciation appear. Ice begins forming in the northern hemisphere, marking a transition toward a climate that will one day support repeating ice ages. The atmosphere responds by tightening its circulation patterns, creating stronger winds and more defined storm tracks. Clouds shift into thinner or thicker layers depending on temperature and moisture, forming patterns that resemble the modern sky. As the atmosphere grows more structured, life continues to adapt. Birds migrate using wind currents that have become reliable and predictable. Mammals evolve thicker fur and new behaviors for colder climates. Plants develop new strategies for surviving seasonal changes. The atmosphere becomes the quiet engine driving these evolutionary pressures, guiding life through gentle cycles of warmth and cold. As your breathing softens, imagine the planet wrapped in an atmosphere that has matured into a stable and delicate blend. Nitrogen remains the dominant gas. Oxygen supports increasingly complex life, and carbon dioxide fluctuates in small rhythms influenced by ocean currents, vegetation, and volcanic activity. The sky above holds the memory of every transformation from volcanic haze to oxygen-rich clarity. Let this image settle into your mind as you drift deeper into rest, knowing that the atmosphere has evolved through calm cycles shaped by life, land, and sea into the protective blue halo we recognize today. As you drift deeper into the quiet story of Earth's atmosphere, imagine the planet approaching a new era shaped by cooling climates, shifting continents, and the early stirrings of ice ages that will reshape the world. The atmosphere that surrounds the Earth now carries familiar patterns of wind, clouds, and temperature, moving with a calm rhythm that has been refined over hundreds of millions of years. Yet even in its stability, the air remains sensitive to gentle changes in sunlight, ocean currents, and life itself, responding with soft adjustments that guide the evolution of ecosystems. Imagine drifting into the Pleistocene, a time known for its long cycles of glaciation. During this era, massive ice sheets expand and retreat across the northern continents in slow, repeating rhythms. These ice sheets reflect sunlight back into space, cooling the atmosphere further and influencing global winds. When the ice advances, sea levels drop, revealing new land bridges and altering migration paths for animals. When it retreats, oceans rise again and climates warm. The atmosphere responds to these shifts with changes in moisture circulation and cloud formation. Despite the dramatic nature of ice ages, the processes unfold over thousands of years, creating a gentle, long-term pulse in Earth's climate. Now imagine drifting over one of these ancient ice sheets. The air above is crisp and thin, carrying only a small amount of moisture. Clouds form sparingly, but when they do, they drift slowly across the pale sky, creating a soft, filtered light over the frozen landscape. The atmosphere in these regions becomes a quiet and delicate system, shaped by cold temperatures and stable air masses. These frigid conditions influence global climate by altering jet streams and redirecting winds around the world. As ice expands, the atmosphere changes its patterns in other subtle ways. The cooling of the planet encourages the oceans to absorb more carbon dioxide, lowering its concentration in the air. This shift further cools the climate, creating a gentle feedback loop that sustains glaciation. When the plant warms, the oceans release carbon dioxide, increasing greenhouse effects and melting ice. This cycle repeats through long periods, forming a calm and predictable rhythm in the atmospheric story. Imagine drifting over regions unaffected by ice, where warm climates continue to support forests, grasslands, and diverse life. In these areas, the atmosphere flows more freely, carrying moisture inland and gentle breezes. Rainfall patterns shift during glacial cycles, creating new habitats for plants and animals. Some species adapt and flourish while others migrate following the changing winds and rainfall. The atmosphere becomes a quiet architect of these movements, shaping the distribution of life on the planet. Now imagine drifting toward volcanic regions, where eruptions occasionally send gases and ash into the sky. These eruptions inject sulfur dioxide into the upper atmosphere, forming a temporary veil of reflective particles. The veil cools the Earth for a short period, creating brief but noticeable changes in the climate. Even though volcanic eruptions are dramatic events, their influence on the atmosphere fades with time as particles settle and the sky clears. These eruptions remind us that the air is responsive to both the calm, slow forces of the planet and the sudden pulses of its interior. Speculative ideas quietly enter the story as well. Some researchers suggest that cosmic rays may influence cloud formation by ionizing particles in the atmosphere. If true, this would tie atmospheric cycles to solar activity and even changes beyond the solar system. Others theorize that variations in Earth's orbit, known as Milankovitch cycles, may subtly shape the timing of ice ages by altering the distribution of sunlight. These ideas highlight the delicate interplay between cosmic events and Earth's atmospheric rhythms. As you drift into the later stages of the Pleistocene, imagine humans beginning to appear on the scene. Early people breathe the air that has been shaped by billions of years of calm planetary processes. They rely on the atmosphere for warmth, protection, and oxygen, just as every creature before them. Their fires release small amounts of carbon dioxide into the sky, but the scale is tiny compared to the vast natural cycles that regulate the atmosphere. The sky remains largely untouched by human influence at this time, a quiet and steady presence that supports their survival. Imagine these early humans watching the sky as clouds drift in soft patterns. They feel the changes in wind as seasons shift and learn to read the atmosphere to predict weather and navigate landscapes. The sky becomes not only a physical presence, but a source of story, myth, and guidance. Through their eyes, the atmosphere takes on meaning, becoming part of the human experience, woven into culture and memory. As your breathing slows, picture the Earth now wrapped in its nearly modern atmosphere, shaped by ice ages, forests, oceans, and ancient microbes. The air holds nitrogen as its base, oxygen as its life-giving breath, and carbon dioxide in delicate amounts that influence climate. Clouds form in familiar shapes, winds move through predictable paths, and seasons follow long-established rhythms. Let this image settle gently into your thoughts as you drift deeper into rest, feeling the calm presence of an atmosphere that has matured into the stable and protective sky we know today. As you drift further into the quiet final chapters of Earth's atmospheric evolution, imagine the world approaching a time when the sky begins to resemble the one we see today. The long cycles of ice and warmth have shaped the continents, the oceans, and the winds, creating patterns that settle deeper into stability with every passing millennium delay. The atmosphere now carries a familiar blend of gases that drift gently around the planet, forming layers of calm protection and soft motion. Each breath of wind, each drifting cloud, continues a rhythm that has been refined by billions of years of subtle interaction between life and the physical world. Imagine drifting above the last great glaciations as the Pleistocene nears its end. The enormous ice sheets that once covered northern continents begin to melt slowly, releasing vast amounts of fresh water into the oceans. As the ice retreats, the Earth brightens, less sunlight is reflected back into space, and temperatures rise in a gradual and steady pace. This warming alters the atmosphere's circulation patterns, allowing new rainfall routes to form and forests to expand across northern regions. The air becomes slightly warmer, slightly moister, and more dynamic as climates shift and ecosystems respond. Now imagine drifting over the expanding grasslands of the world, where new species begin to spread across open plains. Ungulates graze in quiet herds, their breaths releasing carbon dioxide into the sky, while grasses absorb it through photosynthesis, returning oxygen in calm, steady cycles. These exchanges shape local climates and influence the chemistry of the air in subtle ways. The atmosphere supports these new ecosystems by delivering seasonal rains, forming clouds above windswept plains, and carrying seeds and spores across continents. As forests return to higher latitudes, imagine the atmosphere responding with new patterns of moisture. Trees release water vapor through their leaves, which rises into the air and forms clouds that drift outward, delivering rain far from the forests themselves. This process, known as biotic pumping, connects distant regions through quiet atmospheric pathways, showing how life shapes climate as gently as climate shapes life. The sky becomes an active participant in the expansion and movement of ecosystems across the planet. Now imagine drifting into coastal regions where rising sea levels reshape shorelines. As oceans warm, they evaporate more water, which increases humidity and forms thicker cloud layers in some regions. These clouds reflect sunlight, cooling the surface slightly, while also transporting rain inland to nourish growing forests and wetlands. The atmosphere thus becomes moderator and messenger, carrying warmth, moisture, and energy in balanced flows that help stabilize the climate after long glacial cycles. Speculative ideas whispered gently through this part of the story as well. Some scientists suggest that passing through interstellar dust clouds might subtly affect Earth's climate by dimming sunlight or changing charging in the upper atmosphere. Others wonder whether faint variations in the sun's magnetic activity could influence cosmic ray levels, which in turn may alter cloud formation. While uncertain, these ideas illuminate how the atmosphere is part of a larger cosmic environment, always in quiet conversation with space itself. As you drift forward in time, imagine the Holocene arriving, a warm and stable period that begins around 12,000 years ago. During this era, the atmosphere becomes calmer and more predictable, forming the gentle climate stability that allows human civilizations to bloom. Rivers settle into reliable patterns, rainfall supports the growth of agriculture, and winds guide early navigation. The sky above becomes both shelter and guide for human societies, shaping their culture, memories, and daily rhythms. Under this steady atmosphere, early humans learned to read the winds and clouds, understanding when rain will fall and when seasons will shift. They breathe the clean mixture of nitrogen, oxygen, and trace gases that has been shaped by countless generations of life. The atmosphere protects them from harmful radiation, warms them through greenhouse gases in delicate balance, and carries the moisture that feeds their crops. The sky becomes a silent companion to their growth. Imagine the atmosphere during this early Holocene period as a clear and vibrant dome filled with familiar blue light. Oxygen levels remain steady, providing the breath of life for forests, animals, and people. Carbon dioxide remains low enough to support cool, stable conditions, yet high enough to sustain plant growth. Winds carry seeds across vast regions, allowing forests to recolonize lands once covered by ice. Rainfall patterns settle into cycles that nurture rivers, lakes, and fertile valleys. As your breathing softens, picture the Earth wrapped in this gentle version of the modern atmosphere, a calm and balanced mixture, tuned to support rich ecosystems and the early development of human culture. The sky's layers remain in harmony, the troposphere alive with weather, the stratosphere holding its protective ozone shield, and the higher regions merging quietly with the edge of space. Let this image settle into your mind as you drift deeper into rest, feeling the quiet, protective presence of an atmosphere that has reached a state of stability, shaped by all the long and patient transformations of Earth's deep past. As you drift deeper into the calm story of Earth's atmosphere, imagine the Holocene world unfolding beneath you, a world warmed by gentle sunlight and shaped by the steady rhythms of wind, clouds, and rain. The atmosphere now carries a familiar balance of nitrogen, oxygen, and delicate traces of other gases, forming a soft and protective blanket around the Earth. This period is marked by stability, a stability that supports the growth of forests, the spread of wildlife, and the early rise of human communities who begin to interact with the sky in new and meaningful ways. Imagine drifting above early human settlements built along riverbanks where the air is fresh and clean. People gather around small fires whose smoke rises quietly into the sky, carrying tiny particles that mix with the air before dispersing into the winds. These early interactions between humans and the atmosphere are gentle and almost invisible when compared to the natural cycles that regulate the planet. The greenhouse gases released are small in scale, and the atmosphere absorbs them without noticeable change. The sky remains clear, steady, and resilient. As agriculture spreads across fertile valleys, imagine how human activity starts to influence the landscape. Forests are cleared for crops and grasslands expand under cultivation. These changes alter the way the land absorbs and reflects sunlight, which subtly affects local climates. Fields release moisture differently than forests, and this changes the formation of clouds and the timing of rain. Though small in impact at this stage, these interactions show how even the quiet actions of early societies begin to enter the long story of the atmosphere. Now imagine drifting across oceans where the air and water continue their peaceful exchange. Warm currents release moisture and carbon dioxide, while cooler regions absorb them, creating stable climate patterns that drive seasonal cycles. The atmosphere becomes a network of soft pathways connecting continents through winds that carry seeds, birds, and gentle rains. This system nurtures forests, grasslands, and wetlands that support the spreading human population. Picture the expansion of forests across Europe, Asia, and the Americas during the early Holocene. These forests release oxygen through photosynthesis and create cool shaded microclimates beneath their canopies. Trees draw moisture from soil and release it into the air, forming clouds that drift over mountain ranges and drop rain far from their source. The atmosphere gently responds to the growth of these forests by redistributing rainfall and forming stable wind patterns that support entire ecosystems. Speculative ideas add a soft layer of intrigue to this period as well. Some scientists propose that small variations in solar output may have influenced early Holocene climates, contributing to warmer or cooler centuries. Others suggest that volcanic eruptions may have created brief periods of cooling by injecting fine particles into the upper atmosphere. These events demonstrate the delicate sensitivity of the sky to subtle changes from both Earth and the cosmos. Yet the atmosphere always returns to balance after each shift. Now imagine drifting into high mountain regions where the atmosphere thins and air becomes colder. These regions influence global wind currents by creating barriers that redirect air masses, forming predictable weather systems. Snow-covered peaks reflect sunlight back into space, cooling the air that flows around them. As snow melts in warmer seasons, it feeds rivers that nourish valleys below, connecting the atmosphere to the water cycle in a quiet but essential way. As human societies grow, villages become towns and towns become cities. Smoke from homes and pottery kilns rises into the air in thin wisps, adding tiny traces of particles to the atmosphere. These particles help clouds form and influence local climates, yet the overall effect remains small. The atmosphere still behaves as it has for thousands of years, maintaining its gentle stability across regions. Imagine the atmosphere during this time as a vast canvas painted with soft gradients of blue during the day and deep shadows of indigo at night. The winds travel familiar routes shaped by mountains, oceans, and seasons. Rain falls in cycles that support crops, forests, and animal migrations. Storms drift across continents, but follow predictable paths formed by the steady circulation of air. As your breathing softens, imagine that you are floating high above this ancient yet modern world, watching the atmosphere work with quiet grace. Nitrogen forms the stable foundation. Oxygen supports life in every corner of the planet, and carbon dioxide remains low enough to maintain cool, gentle climates. The ozone layer continues to shield the surface from harmful radiation, allowing life to flourish under a protective veil. Let this image rest in your mind as you drift deeper into calmness, feeling the soft presence of a mature atmosphere shaped by countless interactions between life, land, and sea, and ready to support the next chapters of human history. As you drift further into the calm progression of Earth's atmospheric story, imagine the world moving through the later Holocene, a time when human civilizations begin to shape landscapes more noticeably, while the sky continues its steady and gentle rhythms. The atmosphere remains stable in its composition, dominated by nitrogen, enriched by oxygen, and balanced by delicate traces of greenhouse gases that keep the planet warm enough for life. Yet even in this stability, small changes ripple through the sky as forests shift, oceans breathe, and human activity quietly expands. Imagine drifting above early civilizations along the banks of great rivers, where fields of grain ripple under soft winds. Farmers sow crops using the predictable cycles of rain and sun, supported by an atmosphere that delivers seasons with reassuring consistency. The air carries moisture from distant oceans, bringing life to these early agricultural centers. In return, the planted fields reflect sunlight differently than natural forests, creating subtle shifts in local temperatures and humidity that gently influence the formation of clouds. Now imagine drifting over growing settlements where cooking fires release small plumes of smoke into the atmosphere. These plumes drift upward, mixing with the air and forming tiny particles that can serve as seeds for cloud droplets. Although the scale is still small compared to the vastness of natural cycles, each wisp of smoke becomes part of the atmosphere's ongoing conversation with life. The sky absorbs these changes with quiet resilience, adapting its patterns without losing its calm balance. As societies advance, trade networks span continents, and people begin to move across deserts, mountains, and oceans guided by the winds and stars. The atmosphere becomes a silent companion to these journeys, providing clues through cloud shapes, wind patterns, and shifting colors at sunrise and sunset. These early navigators read the sky, intuitively understanding its moods long before the science of meteorology existed. Their connection to the atmosphere becomes part of human culture, reflected in stories, myths, and rituals that honor the sky. Imagine now drifting over vast forests in Eurasia, Africa, and the Americas. These forests continue to play a crucial role in shaping the atmosphere by capturing carbon dioxide and releasing oxygen through photosynthesis. As trees breathe, they influence humidity, generating moisture that rises into the air and forms clouds. This cycle creates rainfall patterns that sustain life far beyond the borders of the forests themselves. The atmosphere, in turn, delivers seasonal rains that allow these ecosystems to flourish, forming a gentle feedback loop between the land and the sky. Speculative ideas also add quiet layers of intrigue to this part of the story. Some researchers propose that subtle shifts in Earth's orbit, known as Milankovitch cycles, may have influenced climate during the Holocene by changing the distribution of sunlight across seasons. Others suggest that periods of heightened solar activity could have altered the flow of cosmic rays, affecting cloud formation. Though these influences remain uncertain, they remind us that the sky is shaped not only by Earth, but by the cosmos surrounding it. Now imagine drifting into colder regions where winter storms sweep across the land, carrying snow that blankets the ground in soft white. The atmosphere in these regions becomes crisp and clear, with cold air sinking and warm air rising slowly above it. These motions form the jet streams high in the sky, fast-moving rivers of air that influence weather across entire continents. Even in ancient times, these patterns existed, quietly guiding storms and shaping seasonal rhythms that people depended on. Imagine traveling to coastal regions where warm ocean waters meet cooler winds, forming fog that drifts inland like a soft gray veil. This fog nourishes plants, creates unique ecosystems, and influences local climates. The atmosphere acts as a bridge between ocean and land, carrying moisture in delicate layers that support life in surprising ways. Each breath of wind is part of a global cycle that connects distant regions through gentle exchanges of heat and water vapor. As human populations grow, forests are cleared for agriculture, and cities begin to expand. These changes influence the atmosphere by altering the amount of sunlight absorbed by the land and the movement of heat between surface and sky. Yet the composition of the atmosphere remains almost unchanged, held in balance by vast natural systems that continue regulating carbon, oxygen, and nitrogen. The sky remains resilient, absorbing small fluctuations and maintaining the conditions needed for ecosystems to thrive. Imagine drifting above early cities lit by fires at night. The glow from these fires rises into the haze, giving the sky a faint orange tint. People look upward and see stars shining through the thin smoke, forming constellations that guide their stories and beliefs. The atmosphere acts as a canvas upon which human imagination is projected, turning the sky into a source of wonder and comfort. As your breathing softens, imagine the earth wrapped in a nearly modern atmosphere, calm, stable, and clear. The air carries the memory of ancient oceans, volcanic eruptions, forests, and early civilizations. It provides warmth, protection, and the breath of life, holding the world in gentle balance. Let this vision drift through your mind as you relax deeper, feeling the soft presence of an atmosphere shaped by time, life, and the quiet resilience of natural cycles. As you drift deeper into the final chapters of Earth's atmospheric journey, imagine the world entering a time when human societies expand across continents, forming civilizations that flourish under a sky that has remained stable for thousands of years. The atmosphere carries gentle winds, predictable seasons, and a delicate balance of gases that support forests, oceans, and life in all its forms. This stability becomes the foundation upon which early cultures rise, each one shaped by the patterns of weather, rainfall, and sunlight that drift through the air. Imagine floating above ancient fields where farmers cultivate wheat, rice, and barley. The atmosphere plays a quiet, essential role in these early agricultural societies by delivering the rains that nourish crops and by providing the stable temperatures necessary for plants to grow. Sunlight passes through the sky in soft, golden waves, warming the soil each morning. Clouds gather in predictable rhythms, drifting over river valleys and gently releasing rain that sustains the harvest. Without this calm atmospheric cycle, early human settlements could not survive, let alone thrive. Now imagine drifting over coastal cities where sea breezes flow inland, carrying moisture and regulating temperature. These breezes form as warm air rises over land and cooler air sweeps in from the ocean, creating a daily cycle that shapes the climate of entire regions. The atmosphere becomes a gentle messenger between ocean and land, distributing heat and moisture in ways that support dense populations along coastlines. People learn to trust the rhythms of wind and tide, using them for travel, trade, and navigation. As you drift above deserts, imagine the atmosphere at work even in the driest regions. Hot air rises from sun-baked sand, creating powerful thermals that lift dust particles into the sky. These particles drift across continents, forming faint, hazy layers that influence cloud formation thousands of kilometers away. Even in these harsh landscapes, the atmosphere behaves with quiet precision, regulating temperature through the rise and fall of heated air. Deserts become part of a global cycle that moves particles, nutrients, and energy through the sky. Now imagine drifting over forests where the air is thick with the scent of leaves, resin, and soil. Trees breathe in carbon dioxide and release oxygen, forming a calm exchange that has shaped the atmosphere for hundreds of millions of years. Water vapor rises from their leaves, forming clouds that drift gently overhead. Forests act as giant natural pumps, sending moisture into the atmosphere, which later falls as rain in distant regions. Through these processes, forests help regulate temperature and humidity, creating stable climates that sustain life. Speculative ideas add soft layers of intrigue to this chapter as well. Some scientists propose that minor changes in Earth's magnetic field could influence atmospheric circulation by guiding charged particles in the upper atmosphere. Others suggest that variations in solar radiation might subtly affect cloud patterns over long periods. Though uncertain, these ideas show that the atmosphere is always in quiet conversation with forces beyond the Earth itself, shaped by the cosmic environment through which the planet drifts. Imagine drifting toward regions where mountains rise like ancient guardians. The atmosphere interacts with these towering formations by lifting moisture-laden air up their slopes. As the air rises, it cools, forming clouds that release rain on one side while creating dry winds on the other. These interactions between mountains and sky shape entire climates and ecosystems, influencing where forests grow, where rivers flow, and where people settle. The atmosphere becomes a sculptor, shaping the land through the soft movement of air. Now imagine drifting into colder latitudes where seasonal changes become more dramatic. In winter, cold, dense air sinks, forming high-pressure systems that bring clear skies and stillness. In summer, warm air rises, creating storms that sweep across the land. These seasonal patterns form the basic rhythm of life for plants and animals, guiding migrations, flowering cycles, and breeding seasons. The atmosphere acts as a quiet conductor, orchestrating these changes with gentle predictability. As human societies advance, technology begins to influence the atmosphere in new ways. Fires used for metalworking, pottery, and heating release small amounts of carbon dioxide and particles into the air. These additions are still tiny compared to the vast natural cycles that maintain balance. The atmosphere absorbs these changes without shifting its fundamental composition. Yet these early interactions mark the beginning of a subtle relationship between human activity and the chemistry of the sky. Imagine drifting above ancient trade routes where caravans move across deserts, guided by stars and winds. Sailors navigate across seas using the patterns of clouds and the steady direction of coastal breezes. The atmosphere becomes both a tool and a companion, offering clues, guidance, and protection. It shapes the early history of communication, exploration, and discovery, long before scientific understanding emerges. As your breathing softens, picture the Earth wrapped in an atmosphere that remains clear, stable, and nurturing. Nitrogen and oxygen drift in perfect proportion, while carbon dioxide stays low enough to maintain gentle warmth. Clouds form in delicate layers, winds move in familiar patterns, and rainfall nourishes ecosystems that stretch across the continents. Let this image settle deeply into your mind as you drift further into rest, feeling the quiet presence of an atmosphere that has reached near modern form, shaped by time, life, and the graceful rhythms of the natural world. As you drift deeper into the final movements of Earth's atmospheric evolution, imagine the world entering a time when human civilizations grow larger and more sophisticated. Yet the atmosphere still holds its ancient calm, its patterns shaped mainly by forests, oceans, and the gentle cycles of climate. The sky above remains stable, clear, and quietly protective, a soft blue canopy that supports life with steady warmth and breathable air. Each drifting cloud, each passing breeze plays its part in a delicate balance refined over billions of years. Imagine floating above early empires, rising along fertile river valleys, where agriculture has become highly organized. Farmers understand the rhythm of the rains, the timing of the monsoons, and the patterns of seasonal winds. They depend on the atmosphere to deliver moisture at the right moment, and to keep temperatures within the range that allows crops to flourish. The sky becomes a silent partner in their success, guiding the prosperity of entire civilizations through its calm and predictable cycles. Now imagine drifting above great forests that still cover much of the world. These forests continue shaping the atmosphere, through photosynthesis, releasing oxygen and absorbing carbon dioxide in gentle exchanges that influence climate and weather. The leaves of trees release water vapor into the air, forming clouds that drift outward, carrying rain to distant lands. Through this quiet process, forests act not only as lungs of the planet, but as engines of moisture flow, connecting ecosystems through the sky. As you drift westward across continents, imagine grazing animals moving in vast herds across open grasslands. Their presence affects the atmosphere in subtle ways. Their breathing releases carbon dioxide, while plants absorb it. Their grazing encourages new growth that strengthens the exchange of gases between land and air. Even these small interactions play a part in shaping the atmosphere's composition, weaving life into a cycle that extends upward into the sky. Civilizations expand further and people begin to burn wood, charcoal, and other fuels in larger quantities. Smoke rises from homes, workshops, and kilns, forming thin, hazy layers above growing cities. These layers contain tiny particles that influence local climate by scattering sunlight and serving as seeds for cloud droplets. While the scale remains small compared to natural forces, these early emissions show how human activity begins entering the atmospheric story, one quiet wisp at a time. Imagine drifting high above mountain ranges, where winds rush over peaks and valleys, shaping climate far beyond their origins. As air rises along slopes, it cools, condenses, and forms clouds that release rain and snow. When the air descends, it warms, creating dry regions on the leeward sides. These interactions form natural barriers that divide climates and influence the distribution of life. The atmosphere works with gentle precision, sculpting landscapes through the movement of moisture and energy. Now picture the oceans of this period still acting as vast regulators of atmospheric chemistry. Warm waters near the equator release carbon dioxide, while cooler polar waters absorb it, forming a quiet but powerful exchange. Ocean currents circulate heat around the planet, influencing winds, storms, and rainfall. The atmosphere and ocean remain intertwined partners in climate regulation, connected through evaporating water, drifting clouds, and soft rainfall that returns to the sea. Speculative ideas also drift through this chapter, adding depth and curiosity to the story. Some scientists wonder whether large volcanic eruptions that took place in distant regions may have injected ash into the stratosphere, altering sunlight and cooling parts of the world for years. Others imagine that small fluctuations in solar activity may have created extended warm or cool periods, influencing crop yields and the migration of human populations. Though subtle, these cosmic and geological influences remind us that the atmosphere responds to many gentle forces beyond human control. Imagine drifting over ancient roads where travelers watch the sky for signs of weather. They raid cloud formations to predict rain, study wind patterns to plan journeys, and follow the cycle of stars to mark the seasons. The atmosphere becomes a guide, a calendar, and an omen shaping the decisions and beliefs of countless generations. Through calm observation, humans form a deep relationship with the sky, seeing it not only as air but as a messenger of nature. As societies grow larger, trade expands across continents and oceans. Sailors rely on the steady patterns of trade winds and monsoons to navigate long distances. These winds, shaped by temperature differences between land and sea, blow with calm consistency, guiding ships across vast waters. Without these predictable atmospheric patterns, exploration and cultural exchange would unfold far more slowly. As your breathing softens, imagine the world wrapped in an atmosphere that is nearly identical to the one we know today. Nitrogen fills most of the sky, oxygen supports life in every corner of the earth, and carbon dioxide remains in gentle balance, moderated by forests, oceans, and geological processes. Clouds drift in familiar shapes, winds follow predictable paths, and the seasons bring cycles of warmth, cold rain, and growth. Let this vision settle peacefully into your mind as you drift deeper into rest, feeling the quiet, steady presence of an atmosphere that has evolved through countless gentle steps, bringing the Earth into a state of balance that sustains all life.